how we got where we are and why this is so complicated, and what were our objectives originally, which are somewhat different than we're actually doing today. So I joined CoprHD as a few engineers VP. Al was basically doing effectively, the overall design, product management, and everything around it. And partly this was his idea. So I think the first question was, okay, so if you want to automate storage cloud in an enterprise, which is a typical EMC customer, possibly in a storage provider environment, what do you need to do? Also, the first thought is, okay, so the first thing is you want to automate some common operations that people perform on storage arrays. Volume create, volume delete, take a snapshot, and so on. And you need to take it into account that, especially in an enterprise environment, people will have all kinds of arrays. I mean, there's no customer that says, only 2 or 3 flavors of EMC arrays. And moreover, even arrays from a single vendor have completely different APIs, how you manage this volume creation, volume deletion, what is complicated. Moreover, if you look at these arrays, they typically have credentials for some super user storage administrator who can configure them, create this volume, delete volume. But you cannot give this credentials to every user in the corporation or every user who is supposed to create volumes on this array. Right? So this is why most enterprise customers will say, well, we need Active Directory or LDAP to authenticate users, and then they have some privileges, but then don't want really to manage it in the arrays. You want to manage it at the higher level, who can see which arrays and so on. Also, when we started, we were aware, it turns out that most of these arrays are, fiber channel CAN connected devices. Some of them are internally very complicated. They allow you, to create different classes of service and so the issue is basically how do we automate the whole procedure of creating volumes and deleting volumes, a simple operation, while leaving the storage administrator's ability to set up, divide this storage arrays into something that is very fast, something that is slow, different classes of service. That is how we allow people who administer this storage to do whatever they do today, but to simplify the life of this end users who, before Viper and things like also Spark Cinder, were at the point where they had to submit IT tickets, I need a volume or a bunch of volumes for my application. A few hours later, this order was approved by their managers, and then they were getting this volume created by somebody in IT. And sooner or later, IT people were getting tired, and they were saying, okay, why are you asking for 500 gigabytes? I give you 20 terabytes come next month, right? The end result is, of course, that you have over-provisioned storage dramatically. People are, there's lots of unused stuff, there's some stuff that is just hanging around. So, on one hand, you want to simplify these operations from the top, that people can take as much as they want, they can return stuff that they are not using, and you can measure stuff that is used somehow. But from the bottom, people can configure whatever they want, and also these guys who consume storage, they can get not the common denominator of whatever we figure out between EMC, HP, IBM, etc., but that they can take advantage of all the characteristics of these arrays that are available, right? I think this is really an essential part, because many of these pre-existing approaches to this problem were, coming, okay, we can only, support what is supported on every array, right? Sort of kind of Java approach to operating systems. There are no symlinks because Windows don't have symlinks of all other operating systems. And I think that really the very essential thing here is that we came up with this abstraction, and Hal was one of these people who really with them. Came later, but there's a V array and V pool. V array, we basically, we look at these characteristics of this array two-dimensionally. So one dimensionally is basically, some connectivity within the data center. Look at if you provision volume for a particular host, and there's a bunch of arrays that are equivalently connected to the SAN network. You can basically treat them as one array. It doesn't matter for the end user where you create this volume. Right? So you basically say, okay, this good SAN or IP connectivity in case of NFS, this filer is the V array. You look at this whole abstraction, and basically as a storage administrator, I just let my automation software to provision on this one abstraction. And the other abstraction is quality of service to some extent, right? So performance characteristics of the arrays or some special features of this array. And in that case, we have something called vpool. So if you assign similar arrays with similar characteristics or identical, so to particular vpool, then as a user, I just ask, please give me something from this vpool. And it could be, simply gold, silver, bronze, or I can have something that has, some special characteristics and so on. So the storage administrator can configure this array in any way possible, right? Then assign what goes to which vpool and which arrays are in the same V array. And as a user, I come and I specify either V array or vpool, and I get something that is just connected. I don't care what I need. I just need some storage. Or if I care, I'm running database and I need for particular volumes, I need particular quality of service I get from particular vpool and so on. And of course, you would like to provide AD control, some access, some permissions, who can access which, who can see which storage, right? Because part of this is that you may not like to expose some very expensive storage to some general users, vice versa. You may decide that, some storage is visible to everybody, but so these were the objectives, right? So now the question is, okay, so what do we start? Okay, so I will reverse history a little bit, but we started basically, we were thinking, okay, volume create, volume delete, take a snapshot, and so on. And use this concept of V arrays, vpools to decide where we do it. So the next thing that happened was we had an early version of Viper, very, very, very early. We went to a internal...
When was that? Early version of Viper?
This was like fall 2012.
Long enough that we have to...
Okay, so in essence, I think, Sal started thinking about this with other people before around 2011, I think, maybe it's earlier. Viper really started like late 2011. We started writing code in March 2012. Right. In fall 2012, we did alpha deployment with an internal customer. And we pretty much learned, okay, so you solved the problem that people were sending tickets to IT to automate provisioning of storage on the array, creating volumes and deleting volumes. Great. We still need to configure switches, some switches, and we still need to configure the initiators on user host, right? But users can configure this host on their own, but they need to get information, so you could actually automate this to the very end. That was, somewhat eye-opening. You have this first, real customer, not your own quality assurance, and they instantly find out. So over time we just extended this to the full stack, so that we can do end-to-end provisioning. We can do these elementary operations, but we can also do the end-to-end provisioning of volumes created on this heterogeneous array SAN fabric and common SAN fabric, and the initiators on the host to get end-to-end solution. And of course, then we also discovered other things like, oh, everything you need to pretty much do multipassing. And I mean, so requirements were evolving as we approached, alpha customer, beta customer, and the team was basically crunching like crazy getting all these things implemented, right? So, in essence, I don't think that, we discovered anything really flawed in this original concept, besides maybe nomenclature that was very confusing originally for people. But over time, we discovered that we're still discovering that go to the next customer and they need yet another higher level abstraction in this provisioning that is actually, unlike, the provisioning of storage on Amazon, the real life enterprise use cases are much more complicated because people want many copies of data. They have specific requirements regarding performance, but they have existing applications that rely on this. It's not like that you can teach everybody, well, it's EBS and something, you don't know what it is, right? Obviously, I mean, so EBS solves this problem differently. I mean, they have actually different storage depending on what you are doing. I mean, they dynamically change what storage you're getting. But so anyway, so having these requirements, the next point was, okay, so how do you implement this thing, right? So people before us, try to write Python scripts. Why not? I mean, obviously, when you think that there could be more than one user at a time, especially if you try to really solve the problem for the enterprise, not to create a solution that, every department has an own Viper, but that you have one Viper that manages multiple data centers. Scripts may not exactly cut it, right? Okay, so probably the next approximation would be, okay, so I have some database to maintain, all my provisioning operations and to perform transactions and to maintain concurrency, and then I do Python scripts that talk to the various database, right? And of course, if you look what other people are doing, I mean, so you can decouple this end user client, that it doesn't have to be a Python script always. You basically create REST API and you say, okay, you have whatever language you want on the client side, talk to the REST API, and behind the REST API there is something. So having in mind as goals that, we want something that is highly available, highly concurrent, highly scalable, and so on, we ended up with Java on Linux. Make it highly available, okay, so you build a cluster. And can you go to the next slide, Ben? And but we decided only to focus on the control plane, not to touch data plane. So in essence, Viper never steps in your data path. Even though we try to be scalable and highly concurrent in all these provisioning operations, we don't try to do anything in the data, period. So once we provision these things, your host talks to the array, and VM on the host talks to the array direct, right? We only do this indirect operations and so on. And while we try to provide common REST calls for using these abstractions of D-pool and D-arrays for all possible arrays, the way we actually control these arrays is array specific. I mean, fortunately, pretty much every array requires some different twist on how you perform all these management operations. Some arrays require multiple interfaces, multiple protocols in order to accomplish all this thing and so on. So it's somewhat unfortunate. Nobody, ever standardized this in the storage industry. In networking industry, it's a little bit simpler probably because, Cisco at some point fascinated everybody with iOS and iOS CLI, right? But in storage world, it's a variety of things. There are some standards like SMIS, but then you find out that not everything is implemented, and this implementation is semantically different. Anyway, so for this CoprHD, we say, okay, highly scalable, highly concurrent, highly available, provides this kind of system calls apps internally, does things in a transactional way. And I think this was also an important thing. So if you think about these scripts, everything is great when you succeed in performing some operations. But some of these operations you can do automation have many steps. And example is like setting up replication using recover point is something like, 32 steps. Yeah.
32 to 45.
Okay. So imagine that you fail at this step for 24, right? Of course, I mean, you have two choices. I mean, you either retry with some different, pick some different placement, different resource and try again, or you need to roll back and clean up. If you don't clean up, you left some garbage. And if people keep retrying the same thing, unknowingly running this script, later you run out of your resources because everything got allocated but never used at the end, right? One thing was this kind of transactional behavior that operating systems provide. The other part was, so if you do things concurrently, then you need to make also sure that people not stepping on each other, right? So you have, 100 gigabytes left on the array, and there are two guys who are trying to get 80 gigabytes, and if we don't control things properly, I mean, you just get unexpected errors, right? So what operating systems internally do normally is they either, control this concurrency or retry with a different resource and so on. So, in other words, the thing at the beginning was even OS. Then we renamed it to Project Born. We renamed it to Viper, and now it's CoprHD.
Lots of marketing jobs.
Lots of marketing.
And
you can sometimes
so now,
the code.
No, so now if you look into the code, you will find out that there are many places things are called storage OS. There's some, I don't know if it's still there, but there's some scripts called Born something.
Yeah, a very small number. There was a pretty big effort done to strip Born from the code base, but you'll still find it a few places.
Well, so I did this effort, and I was, I mean, some things were easy to rename, some things were like, well, it's not just renaming files, you will have to change the code because these files are used somewhere. So you will find this thing, I mean, we try to clean this up at some point, but it's difficult. But anyway, it's still the same thing. And can you go to the next slide? Okay, so how do we build this from the inside out? Okay, so we said cluster because it has to be highly available. We'll go to the next thing. So when we decided on the cluster, well, it was like, okay, can we, do it cluster an arbitrary size and so on, right? And there were all kinds of plans, and then at some point in the meeting that was like 2 floors up here, Surya was our VP of engineering, said, okay, I will make it simple for you. 5, 9, and 15 nodes. Three configurations for version 1. All kinds of extensibility of, changing the sizes later. Before we actually ship this thing, we changed this to 3 and 5 nodes and only 2 configurations, and it was good enough, right? So, for instance, if you take into account that you're doing cluster, it's sort of like, any cloud architecture. So you need to think that, it's not like a single node that I know where to find things. So, really divide things in something that will be a stateless application, some layer that will be distributed persistence of the data of the state of the stateless application. Right? Depending how people build clusters, sometimes they keep up, cluster file systems for this persistent layer. Some people pick different technologies. We basically kind of, I'm not sure how this choice was made, but since we decided to use Java on Linux, that time, the kind of reference point for building this kind of distributed clusters was Netflix. They did a lot of work trying to get the Java stack with this kind of distributed databases working in a very solid way. They published what they were doing. They also did open source projects. They used lots of open source, but they also contributed to open source. The Zookeeper and Cassandra clients they developed and improved dramatically. So we went this way. So go to the next one. Okay, so we started with first piece, which was something that coordinates operations on this cluster, has small database based on Zookeeper with the Apache Zookeeper with some wrapping APIs that make this our feature. But it's basically internally 90% of this is just Zookeeper. Right? There's some additional wrappers of APIs that provide our coordination abstraction. And Zookeeper is basically a database that is think about it as a shared memory across the persistent shared memory. Something that is for a small amount of data. Internally has file system-like structure for objects. We have this kind of nodes. Write and read to these objects are atomic. Great thing to be, very similar to etcd or just a newer kind of abstraction, but not Java specific. In essence, you will find out that people, in the code, if you read the comments, interchangeably say coordinator Zookeeper. So then, okay, so Zookeeper is good for, it gives you strong consistency, but it's really not something where you want to perform thousands of operations per second and keep a lot of data. It's really not designed for this. You should assume that all the data that you have there fits somewhere well in your memory. Don't try to store more than the amount of memory they gave to the Zookeeper process, right? So for vast amount of data, for all this provisioning data, and we did, some back of the envelope calculation how much data we are going to have, right? And provisioning data is not that big. Even if you create tens of millions of volumes and you add, snapshots, you get 100 million volumes, and not something really big. But if you start collecting statistics from how these volumes are being used and by whom, so that you can give people a picture which arrays are utilized and which users consume most of the operations per second and most capacity and so on. Which is a very important thing when you build this cloud, because you use common infrastructure for everybody. You want to ask people, well, you are holding that much space, do you really need this? Or, you want to charge people or something like that. So this actually adds a little bit, and for this kind of, sizes of 100 arrays, 10 million volumes, it's calculated, okay, we will need, 200 gigabytes of space, right? So we pick the same as Netflix, we pick Cassandra as a NoSQL database for storing these things. Column-based database, so it supports very fast index of data. It's convenient here. All SQL databases are rather limited. And we decided not to use any bad experience for Atmos, but we decided not to use any SQL databases in 8A configuration, because the problem, that when they get out of sync, the only sensible recovery is you delete one of the copies and you clone copy from another node. And this takes time, creates a window vulnerability. If things fail in the middle, you don't have any good copy, right? With Cassandra, a kind of nice thing is that not only that it's distributed and gives you the same perception as this Zookeeper thing, but with a slightly lower consistency guarantee, but it has basically a built-in mechanism that if one of these connections simply goes down and comes back, it gracefully recovers. It's just built from ground up for these connections not being entirely reliable. Right? And with this architecture, we can tolerate in a 3-node cluster, we can tolerate 1-node failure. So we replicate data to all nodes, both for Zookeeper and Cassandra. 5-node cluster we replicate is 5-way, and we can tolerate 2 failures. So for the zookeeper, I mean, the semantics is pretty much that, zookeeper does this kind of internally 2-phase commit factor thing that you see data always consistently. With Cassandra, we use quorum read and quorum write. It is probably a little bit of an overkill for standard operation, but it guarantees that even if something goes wrong, some nodes crash, come back, and then during recovery another node dies and comes back and so on, that you won't see inconsistencies in fields in a single object because they are stored in a knowledge database. They may be stored separately. If you do an update of a given field, it would be stored separately from the original object. So we made this kind of, this kind of decision to make sure that the thing looks correct. There's some small window of vulnerability always for the database to look inconsistent. If time is wrong or something like that. Let's go to the next slide. Okay, so on top of this, so we added Java libraries for the client for Cassandra and Zookeeper, or basically for our coordinator service and database service. And on top of this, we built a bunch of Java services. And it was a sort of arbitrary choice. Instead of building, taking, say, Tomcat and building this kind of bunch of war files that provide different resources to serve, we actually developed separate Java processes that run different services. And some of them, if you have good amount of memory, consume good amount of memory because database service will cache a lot of stuff, so you want to use a lot of memory for these processes. Controller service is basically something that is memory heavy, other things not that. So what the services do is, the authentication service is responsible for talking to Active Directory, authenticating you as a user and giving you some token or a cookie so that you can for a while interact with this REST API. We use cookies for UI and REST APIs in this kind of low security mode. If you want stronger security, you can use this token, right? That authentication token to, in addition, sign the request and so on. Stronger security. API service is basically, as I will show later, kind of a front end to the controller service. Controller service is this piece that talks to all the arrays in the backend and performs asynchronous operations, cranking on them for a while. API service is just REST API to this, and it also can perform all operations that are non-blocking. Portal service is our UI, and the UI was designed in such a way that UI actually, as I will show later, talks to our REST APIs. There's nothing, that only you can do through, if you can do something through the UI, you can do it through the REST API. There is storage automation service and sys service, which is responsible for things like, upgrades, health monitoring of all these services, restarts, reboots, etc. So this kind of administrative. Next slide. Okay, so then there was, okay, so you have this cluster, each node has IP address. How to make this more user-friendly for the user, right? And, okay, first idea was, okay, we do the CoprHD client, we do some embedded load balancer in this client, complicated. And the idea was, okay, why don't you put just a load balancer, hardware load balancer in front of us, right? So, people software and you tell them, buy some other hardware in order to use it, right? And then, guys who did our UI basically were using also this Nginx reverse proxy, and they said, well, it also does load balancer. We never tried, but because they were using, single nodes for developing UI. And after a while, and we had to do patches a little bit, but it worked great. It works a lot. But I explain that in the next slide probably how this works. So go to the next one. One back. Okay, so it's actually a pair of processes on every node, right? So Nginx listens on two parts, 443 for the UI request and 4443 for all the REST APIs. And it has, each of them has a configuration file that tells Nginx, okay, there are actually 3 nodes, but besides this node on which Nginx is running, there are 2 other nodes, or 5 nodes, right? And in addition, each node is one of these different services that provide REST APIs. Each of them is in a different port. Depending on the prefix in your URL, there's a different port to go to, right? So what Nginx does is that it basically kind of parses the URL in the request, depending on the source IP address, decides to which the hashes and decides to which node forward this connection. So that's load balancing. No matter to which node you connect, it will hash where you need to fall with your request. And depending on the prefix, matching the prefix in the URL to the list of known prefixes, which actually is quite long because we added so many APIs. Decides to which service you need to be forward. In addition, it monitors, and then the load balancer, it monitors whether the services are actually processing your request, whether they're responding. If they are not responding, if there is somebody dead, tries later, to monitor whether the service allows you to connect again, process the request, and so on. So it's basically doing this kind of health management. Now, how do you know which one you need to connect? So we assigned IP addresses to all nodes, so either 3 or 5 IP addresses for each node individually. And then there is a virtual IP address, and there is this tiny keep-alive-D process that runs on every node. These processes ping each other periodically using VRP, Virtual Router Redundancy Protocol. And they basically, by pinging and monitoring each other, and each of them also monitors whether the Nginx is running, not because I'm dead, or it tries to restart Nginx. But in essence, they decide who owns the disk, right? Only one node at a time will have this disk. One of them decides, well, I'm not good anymore as an Nginx server. Unconfigures this as an additional IP address on this network interface, passes it to another guy. So in essence, it works quite well if you if you kill Nginx or power off one of the nodes, it really instantly trace over to another. But in a big picture, what this means is that your request, even if they arrive to this node, they may get forwarded to another node. So the request went through the Nginx on node 2, but got forwarded to authentication service on node 3, and other authentication service can also send this to another node, right? So it's not like that we are running 3 nodes and each of them is kind of closed entity. This is really like running one kind of more fault-tolerant thing with all services looking at each other on other nodes. So I can kill portal service here, this service here, and so on, and this whole thing will still work. Right? Okay, next slide.
So, one question.
Okay, sure.
So if you were to, let's say, the third node gets the request.
Well, so it's like this. So it's really like this. So let's say the request comes to node 2, right? Because this guy has a disk. And then I find out that the request is for, say, API service. So if I see that the API service on Node, so, and let's say that.
But the actual request is.
Oh no. So the hash is modulo number of live services of a given type. So if this service is down, I either hash here or hash here.
Hash it, and if it's down on that node,
It'll reroute.
I skip it because I have only 2 buckets, right?
To the degree that they're all up, it'll go to the same service each time because of the hash. But if
So obviously there's an interesting situation if I think that the 3 of them are active, right? I cannot read this service. Then I take this service out of this. I have 3 buckets for hashing, right?
you won't see that.
One of them is actually dead. It doesn't work. So service nginx is actually internally retrying. It's really bad. I mean, there's no magic about this forwarding. It's like nginx opens SSL sockets to the outside and uses our certificate. We configure our certificate. And then opens separate connections to this service. So this is not some, magic kernel forwarding, etc. It's really user-level process. It listens to the outside world and then opens connections to our service. And has some buffering for these packets that is also configurable and so on, so that it can retry this request again. So in essence, if I have 3 buckets for API service and I try to go to this API service, I find that it's dead. I simply restructure my buckets. I have already only 2 buckets for this guy, and this needs to retry to wake up that it's alive and so on. Then I hash source IP address modulo these 2 buckets and decide to which one to go. And yes, and moreover, so all services, I mean, so in the current CoprHD implementation, we switched to having all services started by systemd, which means that if they die, they get restarted. And moreover, what this also means that as a developer, if you want to place some jar files for a given service, and you want the service to recognize this new jar file, Q -9 to this process. It will start with your new jar file, right? It's very easy. You don't have to do some, special things. Q this thing, it will start again. Okay?
So all nodes will be configured in the same VIP?
No, so VIP, so VIP is for the entire cluster. At any point of time, only one node has VIP.
So like each node will have the, I think OVS.config property net file, but only one node has that.
So different. So it's this way. So all nodes know about each other's IP address, right? It's not like that we do some discovery magic thing. We just use really a very plain approach. We tell the whole cluster, okay, you have these 4 IP addresses. Node 1 will have this, node 2 will have this, node 3 will have this, and the heap is of 7, right? And all nodes know the same thing. Moreover, they have identical software. The only thing that is different between nodes, this node knows that is number 1, this node knows that is number 2, this is number 3. So basically, they look at this configuration and they say, out of the 3 IP addresses, I'm number 2, so I have the second one. Right?
So only number 2 has this one configured, has the VIP configured.
No, it knows that this is a VIP. Now, keep alive D on every node tries to win, right? The guy who wins says, I have the VIP. The logic how they win is the following. First, they look if they have nginx running on this node. But you don't want to have a VIP if you don't have nginx. If they see that they have nginx, then they basically do a contest who has the higher priority. And the priority is calculated basically for this. If this is node number 1, it's higher priority than node number 2, higher priority than node number 3. If node 1 is available, that has Nginx running, this node will have this. For whatever reason, something malfunctions here, and node 2 wins, right? Two guys have a problem, this guy would have a zip, but it doesn't make any sense because you can't do anything if both nodes have two others. I mean, you will actually connect to something, I mean, it's just a, but anyway, it works this way, right? I mean, if you look at the CoprHD Nginx configuration file, so Nginx configuration is pretty much identical on the node, and CoprHD configuration will use node ID, so it will know that it's 1 key or 2 key or 3 keys, right?
So how do you do the, let's say you have a
very good question. Can you come back to at the end to this? No, I mean, I will talk here. Just remind me at the end. Next slide.
I put it in the parking lot. You can address it in this session.
Okay, so just the fact that we understand how all this machinery works, right? One more time on a real example. So let's try to get the authentication token out of the system. So we do RESTful get login. We provide the credentials for the user, username and password can be checked with Active Directory. So this request comes to Nginx. So we have one connection from the outside that connects us to port 4443. Solutions to if we try to connect, and so in this assumption I assume that this node has zip, right? Otherwise we would connect elsewhere, right? Because other node will respond to zip. And moreover, so there is a tricky part. So if you do something like ifconfig, all these nodes, so depending whether you look, I mean, so there is a difference between, so we support both IPv4 and IPv6 in general. I mean, I think current CoprHD version may have some problems with IPv6, but it's already fixed, or it's going to be fixed. But if you run ifconfig or ip-link and so on, you will see that this IPv4 needs show up completely differently than IPv6, and sometimes you may not see IPv6 unless you use some special options and so on. That's how Linux stack is implemented. But so if you're debugging, you need to kind of make sure that you know what that you're not missing anything, right? But anyway, so you're connecting to Nginx. Nginx will forward this. So we'll look to the prefixes login, right? So it will forward this string to authentication service. Then we will forward this to, so it will ask the source IP to get node 1. And it will forward this to the port, I don't remember, 6, port 443, in which authentication service listens to request. Now, authentication service is a normal REST API process, right? So again, you can actually connect, if you are testing something or developing, you could connect explicitly to node 1, to the IP address of node 1, and connect to this port 6443 and perform this request. Now, in order to do it, however, you need to make sure that you turn off firewall, right? We are using IP tables as the firewall, and firewall is set up that nodes can talk to the port of every individual service directly, but you cannot do it from the outside. From the outside, you can only talk to.
I think in CoprHD we may have the firewall down right now. I'm not 100%.
Yeah. I mean, the code for the firewall is still there. So if you think about, production deployment, you may like to turn it on, right? And of course, then you need to go through the Nginx. But for development purposes, many people just turn it off. Then you can connect directly to all these services without any magic, so you know exactly on which node you fall. But keep in mind, if you try to debug things and you realize, okay, engine X has a zip on port 2, no, 2. And I somehow magically assume, okay, it will use authentication service here, not really. The request will go actually to a different node, so this is why we also developed this log collector gatherer that allows us to merge logs from all the nodes to get like a single view stream of sorted by time, so that you can actually see how your request is propagating, right? There. So the authentication service, again, it's a stateless thing. So this guy will take the password, username, credential of the user, username and password, talk to AD, and try to authenticate. So of course, if this fails, you get a reply right away, sorry, your credentials were invalid, right? If you succeed, then authentication service creates this authentication token, stores this in this authentication database, which is inside of the DB service, so in Cassandra. And then sends a reply back. The reply really goes again the same way. So authentication service uses this connection that it has from engine X to send the reply to engine X. Engine X sends it back to the client, right? So engine X has a table matching these having connections created inside, so they don't work to forward and back, right? Questions? Right, so the essential part here was that this whole authentication thing is really a very quick thing, so we don't need to log for any reason. I mean, we can just wait and expect this thing from AD to come in milliseconds or maybe seconds. This connection this session is used just to send the reply, right? And the other important piece is the one we showed here is the same user logs in from a different source IP address. So they get forwarded to authentication service on a different node. Or to the service that will try to check your credentials, right? This thing is shared between all the nodes. And really, from the programming perspective, you assume that it doesn't matter on which node you wrote to the database, you can read on any other nodes, and everything is consistent. Okay? So it's really a convenient abstraction because you don't need to, writing these stateless services, you really don't need to worry on which node you are. The only thing that you need to remember is that you cannot keep any in-memory state. Every transition in the state that you're doing, you need to checkpoint this either the coordinator service or the reason for this is that if any of these, our assumption is this is a highly available system because if you do it, you checkpoint all the states of the database. All nodes or individual services can die. Service on another node will pick the same item from the database to process and will keep going, right? And? Okay, so next slide. All right, so let's try something more complicated. So let's say we want to create a block volume. So from our external REST client, we send a request on block volume. We specify what kind of volume we want. There could be some query parameters. Again, the same scenario. The request comes to engine X. We are forwarding this type of API service because API service is responsible for this receipt. API service, first thing that it does is text either the cookie or the authentication token with which the request is signed against the authentication database. And so if it finds your token or a cookie in the database, it's fine, we can proceed further. If not, it will basically tell you again, you are not authenticated, go and log in. Now, once you are authenticated, this cookie or a token, security token that was in the request, in this whole block volume request, is really converted internally to your identity. So we know who you are. It is important because if we want to create a volume for you, we need to know which portion of the storage you can actually use, which resources are available for you, which equals or V arrays are available. And this is based on your identity. So in essence, all REST APIs that we do internally in the services, they are nicely annotated with this security tag. We tag, so there are two pieces of this, right? So for all general users, we just convert token or cookie to user identity. In addition, some of these users may have additional roles in this RBAC model assigned. So you may, in general, I mean, in case of block volumes, I mean, it's a general user operation, but if you are performing some administrative operations, it may require, in addition, that you have special roles, otherwise you get rejected. But again, it's not like that we have, some terrible number of special users with fixed, usernames and so on. To the contrary, we basically just assign a role to the users that are in Active Directory. So it could be, some user in some domain and so on, and you can have security administrator role that allows you to do literally anything in this system. But anyway, in this case, it really doesn't matter. The main thing for computing volumes is which resources are visible to you, and this decision was made by the system administrator, where he or she enters volume, enters vehicles or arrays into V arrays and vehicles, right? So if you want this from particular vehicle, we'll check whether you have access to the vehicle. So then we need to, make, in order to actually create this volume, you need to do some work, right? But this work so some work is internal to us. We need to decide what's the best placement. If there's many arrays that fit, many actual storage devices that fit your description of where you want this thing to, when we analyze the people and the array specification. Then we need to decide about the placement. We need to make sure that thing is. But anyway, the observation is creating a volume on a typical storage device takes time. Not instant operation like this authentication with AD. So what we do is we actually did a task, right? And all these blocking operations that we cannot perform instantly, we just put them on the queue, and you can come and check later whether this operation was already done or not yet.
So what is the step number 4? Is it just validating if the volume?
So we create some description of what you really want, right?
Okay.
This is based on the specification of the query parameters and so on and so forth. So we create placeholder for this volume.
But shouldn't that be a part of the task?
So actually, because, could be. I'm not mistaken, the way it is done that we create volume descriptors in Cassandra,
Okay.
which are basically not field yet. I mean, so they have this specification of what you want, but not physical devices are not assigned and so on. And we create a descriptor here that points to this structure. Put this on the list of things to be processed by controller service. This thing is kind of driving work for the controller service and all the nodes, right? And at this point, we return back to the client, and we give you the task ID. So you get UUID that corresponds, well, you ordered creation of this volume. So let's go to the next slide. So the illustration is somewhat complicated because we now try to take this idea of this volume and check whether the volume was created, but we do it for the UI, not directly for the REST API, right? So what happens is we come to Nginx this time not to port 4443, but 443 and in standard HTTPS port for the UI. Nginx forward that to portal service, which is our UI engine, right? And the UI engine doesn't know any magic about, I mean, even though it runs inside of every Viper node, it really doesn't know anything about other services. It only knows our REST API. So what it does is, portal service goes back to this and performs a sequence of REST calls to find out everything that you want to display on this UI page, right? So the UI page will have kind of XML request connections open to, or either web page will have these connections or portal service will do it beforehand, right? So using the page, you can have a static page where you fill this by accessing information for the REST API. Of course, I mean, so this REST API goes to try to get status of the task, so we go to API service. And API service goes to, well, first to authentication database to check who you are again, right? So every REST call gets to the authentication, why this whole messenger for authentication has to be pretty fast. And then goes and checks the status of the task, right? Obviously now there is a question, okay, so how does the volume get created? Well, so originally we created this placeholder volume descriptor and we created task that was specifying that this operation has to happen. And controller service on all nodes basically keeps looking at this queue. If something new pops up, node competes to acquire the task from the queue and start processing this. On placement, perform. Once you decided on which arrays, then they go to this array, try to create invoking APIs, but array-specific APIs to create this volume physically. Once it's created, they update the descriptors and update the tasks that it's done, right? And after the model is that you are basically, as a user, you are calling for this asynchronous task for completion, right? Questions?
So the task operation. Now,
Humble is talking in great extent after lunch about how this is done, right?
Yeah.
Kind of two layers of rollback. That portal service has some orchestration capabilities. There can be some rollback there. And I can talk about the rollback down lower underneath the API. Right. Two levels there. It's easy to get confused when you get in the weeds.
Okay, so now.
So let me elaborate on that one point. Going back to Steve was talking about, some operations, some orders in the UI take multiple. In that case, the UI is maintaining sort of its own.
It's a part of the UI that calls itself the catalog service. So if you're doing a catalog service job, it can be a composite of multiple API calls.
So a good example of that is really two API service operations. So if the export fails, there will be a rollback within the controller service to clean up the export.
Okay, so now, few subtle points, right? So, I said, so we have inside of coordinator service, inside of Zookeeper and UV service, that is Cassandra, we have this objects that were created for this task. And in the crawler queue, we have the reference to this task. When the controller services try to pick something out of this queue, you need some synchronization so that you have a situation that two guys pick up the same thing or two guys fail to pick up the same thing or somebody picks something. So the way it works is that Zookeeper that we use, besides providing this atomic storage nodes in this kind of file system like tree. There's an additional set of primitives built on top of this. So that's the kind of an elementary primitive is read and write to this object are atomic, right? But on top of this, they build primitives that actively give you distributed mutexes for operations, inter-process locks, and so on. Now, this concept is a little bit tricky, right? Because if we have a traditional multiprocessor and you have mutex somewhere that gives you exclusive access to some resource, home machine dies if this mutex dies, but it's not like that 1/3 of the machine dies, what happens to the mutex, right? But here the logic is such that when you grab a lock in Zookeeper, the lock is owned by a particular service. Every service during startup also beacon in Zookeeper. So in ephemeral phase, in this kind of non-persistent phase of Zookeeper, it is actually persistent, but it wipes out on everything in Zookeeper is persistent, but the ephemeral phase is basically the array. Good. So each of these services has a beacon here. And the beacon has a dual role. One is it allows us to navigate which services are alive at a given point of time. In addition, Nginx does its own connections and probing, but for our own purposes, if we try to go from API service to controller service and so on, and we try to know which of them are presently running, we have this beacon. But the beacon has also another role. So it's the locator of the service, right? So what we put there is IP address, colon port, where the service is running. So the service and any name. But the other role of this beacon is that Zookeeper maintains kind of ping-pong protocol on the connections to the beacon. Service dies, the beacon disappears. When the beacon for a given service disappears, all logs for the service are ready. So in essence, if the service dies and it helps some logs, they all go away, so anybody else can get the items that this service held and retry on them. Right?
The detection frequency.
Okay, so the ping pong has fairly high frequency. I don't know, like every few seconds. We allow, I don't remember what is the time method we allow, but it's probably something like 30 seconds or something like that. So in essence, that. But if the service dies gracefully, I mean, if it just exits, then it just cleans it up. Also, if the connections are just reset, it's the same thing. So it's only, the node lost power and didn't do anything nice, right? And somebody else responding to this thing, then you may suffer from this timeout.
So you don't get into any split train.
So we don't get to split brain for different reasons. That we always Zookeeper knows how many nodes it has. Again, I mean, at this point, the current version of Zookeeper does not allow you to add remove nodes easily, although I mean, you could probably do it, but I mean, so right now we don't support changing the size of the cluster. So this is something that probably can be done, right? But with this limitation, so you know exactly how many nodes you need to have. And the protocol is such that Zookeeper will not acknowledge any request if it didn't get half plus one, I mean larger half of the cluster updated. The same is for Cassandra. I mean, this is what we for Zookeeper, this is by default, but for Cassandra, this is what we enforce, right? People typically use some guys like Netflix run most of the data in Cassandra with just one consistency. One node acknowledges, you write to all nodes, but if one of them acknowledges, you say it's good. But they have a different problem. I mean, if you need one, I mean, so this dramatic improved performance, if they lose actually this one update, that means your movie will start, 30 seconds earlier or something like that. Now, on the other hand, one has to be really careful about this, because in our case, if we miss some update, well, this is also why the things where we cannot miss anything, they are here. Things where, something in Cassandra, it may actually get updated on the next, discover and so on, right? Actually, I didn't talk about this, but Tom will talk more about this. And so, while our main focus was automation of operations for this end user who has, AD authentication, and vast number of users, not for the storage administration, we actually did a lot of work automating work for storage administration. So they can configure arrays on their own. We don't do it. But then, in order to configure Viper, you need to enter 100 arrays, right? You don't have to do it manually. You can automate large portion of this process. But Tom will speak more to this. Okay, so then there was a question about upgrades, right? So about upgrades, there's two interesting things. So before we get into upgrades, let me just explain one thing. So these normal locks that you get in Zookeeper, they die with your process or particular node that was running your process, right? They just get reclaimed. Otherwise, you will have deadlock steps. Something died, didn't start again quickly, and who owns this lock, right? Or you could even restart service if you didn't know that it owns the lock. But when we do upgrade, so the upgrade unfortunately, in the CoprHD version, so you do upgrades by reinstalling this RPM, right? With it. So you don't exactly get rolling upgrades. But we can talk, how to add all this functionality. I don't think it's very difficult. All the code is there. You just don't have the packaging that we use, right? But I mean, really, this is as I explained on Google Group, and this is really a small thing to do. But one interesting problem that we encountered where we were implementing upgrades is that in that case you need a log that will actually survive powering up a reboot of the node, right? So you basically want to coordinate that nobody else can upgrade until I'm done. And to some extent, it's a simplistic, approach. I mean, so speaking to your question, you ask, okay, so what happens if so let's go for a simple scenario. So if I simply reboot the cluster, but I don't want to reboot the whole thing at the same time. I don't do any upgrade. I just want to do a rolling reboot, right? So that I don't lose availability. I want to reboot, say, one node at a time. But actually, I should pay attention. I mean, this is kind of a simplification, because the actual condition for the reboot is that you want to make sure that the reboot particular node, the number of instances of every service that has to be running in the cluster minus what is running on this node is still sufficient for cluster to be available. Okay, so because this was one of the first things that we implemented, and we tried to do it in a terrible hurry. We did an approximation of this. Well, if we are rebooting just one node at a time, it should always work, right? I mean, it's like not really exactly stronger condition. It's like somewhat overlapping, but this was the approximation. So we basically have a log that this service grabs on the log when it's basically all nodes. If you decide that you want to reboot the cluster, the way it works is that in Zookeeper, we effectively say, okay, we want to reboot. And all nodes try to reboot. But they have to grab this log. Only one node at a time can grab this log. And it releases this log only when it comes back and checks that the database service and controller and coordinator service on this node are up and running. But if they not, you don't allow the next guy to reboot, because then you will lose availability, right? So you wait actually for the two processes, coordinator service process and DB service process on this node, to come up, initialize, and publish the beacon. Publishing a beacon is the last step in the initialization. And as this service works, because if you think about it, we only need one instance of each of these gray services to be running on the whole cluster, and the cluster is running. But we need at least, in this 3-node configuration, we need at least 2 instances of coordinator service and 2 instances of DB service on a 5-node cluster. Right? So, if we reboot in a 3-node cluster, the second node, not waiting for these two guys to come up, and there is a short window where nothing is responding, right? This node is rebooting, and the other one is probably will finish reboot, but then the short hiccup, right? So, that kind of coordination, I mean, so even in the simplistic approach where we just say, well, reboot one node at a time, I mean, you can make better. I mean, so if you look at Leap, which is part of CoreOS, Kubernetes, and so on, so they do this exact counting of how many services of a given count you need to have, right? Okay, so now, if you think about your original question, if we just think about your original question, so what do you do when something is incompatible during upgrade, right? Okay, so there are 3 types of incompatibilities really that matter. One incompatibility is incompatibility on public APIs. And that's not a good idea. So the good idea is you do some API versioning, and you need to make sure that during upgrades you have at least one guy with this new API, right? But this means if I reboot one node at a time, it will work. We really want to, we're really terrible with this. We changed these APIs many times. And some of them were kind of, unproductive. All the service management APIs were private APIs. Use it only through the UI, so if we change them, you don't see it. But we changed APIs of API service, which are public APIs, between different versions of software. And people who wrote scripts were relying on our APIs. Yeah, true, right? Right now we learned the lesson, and I think the goal for the next release is, well, we need to just version things, create new APIs, deprecate solely the old APIs, and so on. So that's one incompatibility, right? Second incompatibility is incompatibility between internal language, how the service is talking to itself, right? So fortunately, most of the interaction between services is really between API service and controller services, which is the same team, right? So they do it carefully and thoughtfully for interesting things.
But going forward.
So I think the original plan for the, so far we didn't have to worry about it. But again, going forward is the same thing. So in the beacon you can actually publish the version, so if you really know that you're breaking the API, you can change the version number in the beacon, right? Then when you find out if you want to talk from the API service to controller service, so you can make sure that either you support old and new, so then the service can publish even two beacons for version 1, version 2. But you can basically find out who has the right version to which you want to talk, right? So you will not cross step to ports of the controller service, but you will find out which port it is, right? So part of this beacon structure already has the version number. That's the placeholder for this. So now, of course, there will be some first beacon trying to use all this methodology and finding out, what are the possible traps, right? But otherwise, so we really there's not that much communication between the services explicitly. Now, the communication happens indirectly through the assistant layer, right? Because we create objects that are picked by other services. Everything, has some Java client, so you are not really directly reading the thing, but if the schema changes in the database, but we decided that, some objects have now different number of fields, and some fields get removed, some fields get added, right? So for fields that get added, the situation is easy because you're just adding them, right? So the schema conversion is pretty simple, but if some fields get removed or some new fields are getting initialized based on old fields and so on, then during the upgrade we need to perform the schema conversion, and this actually results in a downtime day. So when we started implementing this thing, it was made, oh no, we will change schema only between major versions of software. Which means we will change this during development, but then once we ship version 1.0, 1.1 will have the same schema until we decide version 2.0, right?
Great plan.
Like most plans.
Yeah. Okay, so
Rainbow
first patch, we had to change it. And so we got a little bit smarter about schema change. So we did a few things. We implemented the schema change law so that we can ensure at standpoint development that nobody accidentally changes it. Right? Again, it's not like we have some schema. We have objects that we store in the database. And the schema is effectively, collection of this object, right? So people create this object, change object, they didn't even realize that. Yeah, right? Because when you program this thing, you have just, one folder where you have all these models that you store in the database that are using REST APIs. You don't even think that this is in the REST API or the other thing is in the database, right? You just store them somewhere, and it's like, the programming Java, there are no explicit, I need to now serialize this. I mean, some of the things get just go to some default serialization and get stored in the database. So people sometimes accidentally do it. So we put this database log, the database schema log. We still run into interesting problems. I mean, a few different problems, right? So one problem is that sometimes these callbacks that do conversions are not very well written or not very well tested, which are very important, and they bomb. And originally we basically were entire upgrade bombs. We stopped in the middle. Not a very good idea, right? So it's probably better if you complete and say, well, I encountered this errors and go and fix it, right? Because it's so we, put some code, okay, now the upgrade will complete, we'll record this thing, put some information what has to be returned and so on. Then we run into a different type of problem, So you add more and more functionality, and it's not like, one thing that is to be tested. Then somebody wrote callback that was just taking forever. So some of the callbacks are specific to particular, some of the information in this schema is still specific to particular storage devices. So if that's the thing, you don't realize that there is a callback that only gets invoked if the customer has a large number of arrays with particular type, right? But there was a field added. So the object is universal, but there's some field that is used in this specific case. And we run into the situation where the upgrade was taking 12 hours. So all customers who used to the fact that upgrade normally takes 15 minutes were like, this whole thing died, right? And somebody logged into the system, finds out, no, it's still running. It's just running very slowly. So we're learning. It's not trivial, but we had also. Originally we planned to support upgrades and downgrades, so you could roll back to the previous version. Once we discovered that we need to do the schema changes, so that customers are, no, I want the new version that supports this thing. I don't care about rollback. The rollback takes time to implement. You do schema changes in both directions. So we decided we go only unidirectionally. And what we did is that we implemented more sophisticated scheme that allows to describe whether you can do upgrades or downgrades from a given version to a given version. We allow upgrades. So typically we allow upgrades to particular versions from old past versions, version that we don't believe anybody else is running things, because we don't want to spend months and months testing that. So we test actually that upgrades from this version succeed somehow. And we basically disallow downgrades for the time being. But in principle, you could implement callbacks for the downgrade, so it's not obvious always what to do. And in principle, we could do downgrade. There's nothing. One thing that we'll probably support in the near future is the concept that if you have so there are some people working on how to create a DR of this thing, how to have one active Viper and some standby replicas, right? And one scenario is that, okay, so if I do upgrades, I can upgrade my replica or keep the replica with the old version. Or if I have two replicas, I can do one of each with each of them, right? And in this case, if I don't like, for whatever reason, the upgraded version, but I haven't performed some tremendous number of provisioning operations on the array, I can make a deliberate decision, okay, let me roll back to the previous version with the previous state of the database. Which means basically I delete my database on the active side, restore this from the replica rollback version of software, and I check, right? If I encounter some problem right after the upgrade, I can still go back. I will use only these provisioning operations that I performed after the upgrade. Right? So then you need to somehow make sure that these operations get reverted on the arrays, or you have some, stale data that stale volumes or whatever. Or you can re-index them. Right, so there is no magic solution, but there are various bits and pieces and various things that we thought about that would be needed in the future. They are already in place.
You speak to the geo
Okay, so
model. So I know
okay,
Cassandra does support.
so there are two things. So the geo that we have today have this kind of concept that you say, okay, so if I have two Vipers in two different data centers, I can say, okay, some storage resources are local to this data center, and some are shared between data centers. Right? So you can use each of them to administer this local thing, and the global thing, they will also have, global list of tenants and so on. But for the global volumes and depots and so on,
the object stuff that came out. So really tenancy and projects are the global things.
So we had this, basically, we originally implemented this for object store, and the only thing that was really shared between data centers was the tenancy model product and the object depots, right? Then we split these two products. So now ECF is one product, this thing is another product, right? And it's really not much of the overlap. So now, if you look at the wiki pages, there's right now rapidly evolving page with the design of R, right? Which basically means the following. So you have multiple Viper controllers. One of them is, at any point of time, one of them is active, the other are standby replicas. These replicas have almost synchronous replication. So basically when we write to Zookeeper Cassandra, we forward all the requests to the replicas, we just don't wait for them. We decide to do a graceful failover.
Is it a different instance, or are you talking about the same instance? When you say so you have two Cassandra instances.
Well, two or three or more.
Whatever, yeah. In the simplistic one, let's say you have active passive.
Yes.
So you have two Cassandra instances.
I think even simplistic is actually three of them, because I think that it actually, we thought about it a little bit, and I think, first, the question was, is it enough if we do that active, passive? I don't think it's enough. I think, people want to have, but especially when they do upgrades, they want to have one copy that will keep replicating and the other copy which will have the previous version if I decide to roll back, right? But we already found that some customers basically upgrade and then they say, oh, shoot. Doesn't work for me. How do I go back, right? So, in essence, there's one active at a time. You can have multiple standby sites. Do this replication to all of them. You can, but again, that constraint. So if you do upgrade and you don't upgrade the standby site, you need to pause the replication because there's a different schema for the database. So there are all kinds of interesting constraints. But in essence, the idea is that you can use At any point of time, any one of these vipers is active. All other will tell you to go to the active one. And this active one can manage multiple data sets. So the assumption is, and I think the assumption is kind of implicit, but considering that people use Viper to provision protected volumes, and it's like the most common thing that people are doing, right? That they have Viper running in one data center. They actually manage storage resources in multiple data centers. So they try to create a volume. They really try to create 2 or 3 volumes that are connected with synchronous or asynchronous replication. So considering that we don't run into the problems where customers say, well, but Viper in this data center cannot manage storage resources in the other data center. This is not the problem, not the problem then. You can really have, 3 Vipers in 3 different data centers. Let them use this kind of, NetSpeed type of replication. Because this is pretty much what NetSpeed does. If you watch videos here, your data is updated in US West and in Europe, right? And then if we want to do graceful failover, we quiet all operations, so we know that everything gets synchronized to the standby site, and we promote standby site to an active site.
No.
So as I said, so feel free to comment. I mean, so this is a project which is just starting. There is among other, proposed designs.
Okay. Yeah, the CoprHD wiki, there's a design document that's in active
state. It's pretty long actually, and I expect this will be done somewhere by April. I mean, there are many people waiting.
Authentication, shared tenancy, shared. Not all it gives you right now in its current state.
Well, yes, but the thing with the current view is that if we implement the VR, I actually can view it because nobody's using it. Any questions?
Great update.
Very much integrated with the zookeepers, right? So any kind of distributed file system that has the so every distributed file system has its own sort of cluster management. Step back and look at how you integrate CoprHD with it.
Yeah, it's not the file system. It's really Java service.
Right, but still,
files are local.
Right, if you look at the control plane, like every distributed file has its own control plane.
Okay, so
Not really related, right? So I think you're talking about a control plane within a file system. We are talking about a control plane among the storage resources. That could.
So this is purely internal thing. Okay, so actually, but one important thing. So because all data is stored in coordinator service or DB service, internal, right? I mean, the thing is unrelated to any other, software file system, right?
Okay.
And we make no assumption that there's any, shared storage between these nodes. Like even if you run actually on shared storage, like you deploy the VMware VF, right? You don't take any advantage, which is why using, simple scripts that perform the same actions that vCenter does for instantiating this VM, we have this kind of bash and PowerShell script, and actually deploy this whole thing on plain ESX servers without even vCenter. You can deploy this on Hyper-V.
But you could have all these let's say VMDK files.
Right.
It gets very tricky, but
We don't take any advantage of this.
that's not,
Okay.
We don't know what is, we assume that these are completely, architectural assumption is these are dumb boxes with lots of disks.
Okay.
Whether they are VMs or physical boxes, or whether this is VMware with shared storage or without shared storage, you can have, ESX boxes with local disk drives, right? Could be Hyper-V with local disk
Oh, I
drives.
see.
We don't care.
Okay. Yeah.
Okay, but the important thing is, anything that we have for systems, including coordinator service deletion, no persistent configuration file. Moreover, the way we run this in this production appliance, the software image system, the root file system with all these services, is read-only copy and write image. So it's basically like, pretty much like Docker, right? So if you reboot a node, nothing is preserved within the root file system. We have a separate volume on every node that stores the database file, Zookeeper and Cassandra, right? But again, it's only Zookeeper and Cassandra. There are no other files that you can create. The reason is simple that, okay, if I create a file on this node, how this file gets replicated to other nodes? Okay? So the idea is don't do it. If you want something that's like a file, create a node in coordinator service. If this is big, do it in Cassandra. Now
Yeah, I misunderstood.
Yeah.
One other point to make. No attempt to share any of the distributed infrastructure components.
So this is just an abstraction, right?
No, but even still, there's a distributed systems infrastructure. Have other like our own software storage systems are also distributed systems.
Right.
We
We
don't take
actually
any
started
Right.
down originally a path.
Yeah.
We were building the distributed control plane at the same time we were building our distributed objects. To have them share the distributed infrastructure, that turned out to be a really bad idea.
Yeah.
So
Okay.
completely separated. Now, in the future, hard, and now there's Mesos and Kubernetes and all these kind of as-like frameworks that are popping up to make it simpler. In theory, you could run a distributed storage system and some kind of control plane on top of a Mesos or on top of something else, where you would, but that's like
Yeah, but on the other hand, I think,
a little bit of the future.
if you look at at Zookeeper versus etcd, right? Take some work, you could switch to etcd or make this, agnostic, whatever. I don't think that we're using anything that is like, impossible to do with other
Yeah, I
flavors.
misunderstood it. This is
And this sharing is really, this is a logical abstraction. As I said before on the slide before, each node runs individual processes that participate in this shared life, right? So, one more thing, right? So keep in mind, considering this model that each node has a persistent disk for the database file, these two guys, and really identical root file systems. They all have this additional information with the configuration, what the IP addresses are, what the disk is. Only difference between nodes is the node ID. Everything else is derived, right? So now, both in the RPM-based CoprHD in this production appliance, the standard configuration files, both for these Java services, because they are, all these services are done in such a way that you can really keep developing the service individually in your IDE. You can have some string configuration files for also wiring everything and so on. And these files may have, something that has IP address and so on. All this stuff is populated before we start the services on the client very early in the book. So we generate all the network configuration files for the services from a cached copy of the configuration that is stored here. So we have this kind of look, we basically first configure everything from the cached file. Then when the sys service starts, it checks whether you actually have this file up to date. If yes, everything is good. If not, just update the file, reconfigure everything. Right? Okay, so so the issue is like this. Okay, so if one of these nodes not just dies, but the storage of this node gets damaged. Right? So we lost this database files and so on. So what do you do then? So I think so there are really two answers to this thing. So I think it's very unlikely to happen for the via. That simple reason everything is in the same shared storage. You either lose everything or nothing.
Well, but you just said that the design point, you just got.
I'm saying that in reality, if you're on shared storage, you probably wouldn't lose this one. But
yes.
Design point.
So hold on. So about VS, we don't care. But if you deploy this on Hyper-V or individual ESX servers with non-shared storage, then we have the procedure to recover this kind of load. So if you have still most of the nodes up and running, you can go to the UI, create configuration files for redeploying one node, run a script that redeploys the VM with the same set of IP addresses and ZIP and so on. Deployment of an individual VM. And then the database is going the rebuild process. You can watch the status, the UI page, how far you are, and back to normal. No, actually, because so the scripts for deploying individual VMs. So really, there are like two types of deployment. I mean, you can deploy that works only on VMware as a VIA, which is one click thing. All 3 VMs got deployed in one click, or 5 VMs, right? But the drawback is it all relies, in case of VMware, on the shared storage behind. If you don't want to use shared storage or you want true independence of the VMs, and instead of using one-click deployment, you actually run a script 3 or 5 times. Deploy node 1, deploy node 2, and so on. I mean, the configuration is kept common, right? To deploy individual VMs, and in this model, this works for ESX or vSphere Essentials, and basically without DRS in VMware. It works for Hyper-V, and not a big deal to support the same thing to KVM. KVM will be just, again, different this format, but at this point, adding one more thing is like pretty straightforward.
So the other thing, I know, like somebody made a Docker container thing, so you can deploy that.
No. So Docker container is Docker container. I mean, that's okay, but I mean, so.
No. But
you don't have a hypervisor, but you have a hypervisor. You have a host, right?
No, but there's no hypervisor. No, but I'm saying I know when we had the Viper controller product, we only did the kind of VM-based deployment because it was outside of CoprHD, not.
No, so we have already CoprHD running on Hyper-V. Same.
No, forget Hyper.
Sorry, on Docker.
Okay, but I'm saying all these scripts, all these fancy scripts that we wrote to kind of bring up a new node, we wrote it for VMware. Like, we have those yet, so like the Docker container version, or that's work to be done.
No, so Docker container doesn't even require any script.
I don't think Docker does.
No. Okay, so let me explain what the situation. I mean, we can have a demo of Docker on Thursday if you're guys interested. You can come and show, I mean, this is like 15 minutes end-to-end exercise, right? Okay, Docker does not require any stupid script. You just deploy it. It really takes 5 minutes to build and deploy, right?
Okay.
The problem with Docker, however, is that at this point, I mean, this is not only our problem, that Docker does not support static IP addresses. I mean, it's happening as we speak. I mean, these networks get upgraded to this point, but there are very many people waiting for this. So what we have today, you can very easily deploy single node deployment using Docker. And it's
but even with like, you could use like the host networking mode.
Today with Docker, the problem is that the way they use brick device and they configure, because they try to configure things magically for you.
That's the normal mode. There's this thing called host networking mode, where it doesn't do any of that fancy stuff. And bypass all the crazy Docker networking.
But yes, but then you again you do things on your host that are different. I mean, so if we assume that people don't have to do any extra amount of work, it's better to wait another month and then we'll have it, right? Docker will support this by definition. I mean, if this was a year from now, I mean, we did some research. I mean, we'll probably do this kind of thing that ECS did, but considering that this will be available.
Okay, so let's say it comes in 2 months or something. So by the time we get to the November official CoprHD, the next major or whatever,
We'll probably work out the box.
November, the Docker deployment will be a first class.
Of course. I mean, even this single node is a first class thing. I mean, it's just much easier from development perspective than installing this RTM and so on, because basically your dev kit is just a Docker image and
because even like
integrated
we'll talk
in
tomorrow about OpenStack, and like we're building an OpenStack product for the client. We use Docker to package all the OpenStack components. So it's just a more convenient way to do it. And I'm curious. Our own thing, whatever. It's the similar that didn't exist, but it's the same sort of. The question is, do we think in the world where a containerized deployment of the OpenStack becomes so predominant that, hey, this CoprHD is packaged as a Docker container, just start the CoprHD Docker container instead of, starting the built-in Docker container kind of thing? Do we think that'd be good enough, or there'll still be so many people deploying OpenStack? We do that, but we'd also have to do something else. I don't have a good sense of general.
Again, it depends on. So I'm just purely looking at from developer perspective. VM and then put the packages and then start the development. A container that has everything in it, then start doing the development. Not seen personally a whole lot of development community using it yet. I have not seen it.
But we need to have a conversation about deployment options and things we want to work on. Or
no, I think
then you go from there.
No, I think my challenge with the existing
so demo of the Docker can be done in Ubuntu.
native install on
I'm
Ubuntu?
just talking about native install, not the Docker.
Yeah. So I think my point is that porting this native thing to Ubuntu will be somewhere. I mean, it's pretty straightforward. It's just some work.
It just needs a little bit of stitching here and there.
And then,
packages
down the road, it will require some maintenance, right? Because we invoke some commands somewhere, and there are some scripts, and you need to make sure that they work everywhere, right? The container abstraction is basically you can have a different OS in the container as long as you believe that Ubuntu kernel will work with the user level of 2Z, which means, again, for OpenSUSE and this kind of CoprHD thing may work for like cheap certified environments like this. Unlikely. Right.
Project of make CoprHD work in any particular container environment or make CoprHD work on Ubuntu. Body's working.
You definitely want to go through what is it, 2 or 3 that if you get those 2 or 3 that not OpenSUSE, that we know. It's not OpenSUSE running in VM, that we know.
I mean, if you
No,
look
no,
at
OpenSUSE running in a container on Ubuntu.
no, no.
Well, that's a combination, but does that get us 80% of the development?
No, I mean, if you look deeper,
I understand that, you know,
no,
you
but
can actually get a container to
there are
work
much
on.
bigger drawbacks with this container. So right now, the container size of in which we run is not a microservice. It's 3 times the image of the.
That's what I was saying.
It's not about container. This is about, at some point at the right time, we talk about that deployment, and we need to come up with what are the 2 or 3.
Exactly.
If you cover those, you get 80%.
This came out of the Red Hat meeting as well. The guy who was talking about Gregory, his point was, hey, you guys don't support different distros, so, who cares about Slack? I don't have
Which
Slack on
is a
my
fair
thing,
point, but we need to just identify what
Yeah.
are the top, is it Red Hat or is it Ubuntu? Well, for OpenStack, you probably go Ubuntu.
Yeah.
But whatever, you have to look at.
And then the Docker container. Between those 2, I think you are covered.
But with Red Hat, the problem is that, again, that you cannot distribute the base image.
He came. But yeah, I wanted him to introduce himself.
Hi, I'm John Mark Walker. Momentarily, I work for Red Hat, but that will be changing very shortly.
Hey, I'm saying a guy from Red Hat showed up.
Just to
Think about it. So can I buy a Red Hat and give somebody else the image? I cannot.
Wait, what?
I cannot give anybody Red Hat.
Well, no, that's what CentOS and Fedora are for.
Okay.
But you're talking about specifically RHEL.
So, I don't want to go even CentOS, issues.
It's the same problem we have with ours, with Sled, and why we went Sled rather than what we use for Viper.
But see, you don't have to go with the image, right? I mean, it's not like you have to give an image to a developer. Developer cares about, hey, here is the source code, here is how I build it, here is how I deploy it on a given VM, and I am developing on my VM that I see. You have to use Docker container and the moment you start imposing the rule, that's when you tend to kind of...
No, I understand. The thing is that I got to give you a recipe how to build the base image that you want to use in this container. To be everything that you need. I give you the recipe, not the image. It's a tremendous amount of work to get this to a small, portable thing, right? And Docker just adds things. If you delete things, the space doesn't shrink. You are still using the space even so you delete this stuff, right? I think it's still very early.
Exactly, that's my point.
So if you look at Docker Conf talk, right, what people are complaining about is that, okay, we can use it in production, in development, and we do. Right. We don't use it in production for 2 main reasons. One is that building production quality compact images is very complicated, and the other that there is no static IT support, right? That's Docker can, right?
Just think of
think
of a real image
Yeah.
that has, it's a virtual machine image, let's say, so it has everything on. Something we cannot do.
Right, unless you have some sort of agreement.
That's how we ended up with OpenSUSE as well, right? Because Viper is natively less product, and so, okay, how can we most quickly get something that will work and make the code available and runnable by the community from where we are now? So that was the shortest step. It wasn't because we thought OpenSUSE is great.
There are things you can do to get an NMR version of
It was the
Chrome,
shortest
but
march
but
from
honestly,
everyone.
for downloading images of CoprHD, it's probably better just to use this web, just like where you're going to use OpenSUSE.
So the other part of the deployment, so far we've been talking a lot about from the developer's point of view, which I get, but we also need to think about people who just want to download and use the thing. That's something that we also, because those are the guys who really want to have this easy download, plug and play thing.
See, it's a chicken and egg problem. You make it that easy to download and start actually playing around. If something goes wrong, they have no clue how to troubleshoot that problem. I would rather see them actually do the setup on their own and go through the painful, opposed to just, you make it that easy, you run into a problem, you have no idea where to go.
So that's where that ease of makes sense for our commercial offering.
Right.
Because they have a problem, they pick up the phone, they call in support.
Here it is like
in the case of open source, it's a little bit.
They can do it yourself.
So we just that's what I was asking. So we just concentrate on this for now.
Do it yourself.
Hey, 1 minute, guys. I'd like to give an opposite view to what Reddy said. If we make it so easy to use, maybe more people will use, and then they can always enter a bug or a support question, and then that also protects, money that comes in as service contracts. But at least it's easy to use.
I think of most open source, not commercial offerings, but most open source things, they're not.
You get any, exactly.
They're not packaged with that.
It takes some work, and then probably somebody has a packaged version that they can get quickly just to see. Like I did that.
But that's the commercial.
Yeah, switch over to the commercial version.
What about the vagrant thing the guys do?
The vagrant thing is awesome.
That will come to solve how you can use Docker, including how you can build it.
No, Docker's awesome. We have.
Vagrant's great too. I've been using Vagrant this whole time.
My point is that Yoni can show you how to build Docker image on your machine, and also how to do it using.
But also, I think if people want to kick the tires, they'd also just go use your simulator online too. That thing's pretty nice to show. Just, hey, what are all the menus? How do I thing? It's not using the hardware, but it at least gives you an idea of what it contains.
Okay. So let's figure out how to get developers up and running fast. Oh, Reddy, you really think it's better to have a list of instructions rather than?
Yeah.
I mean, because we could have, a VMware one, a KVM one, and whatever the technologies are, and then we say, here, deploy or start working.
You can.
Better?
I mean, yeah, you can, but I have not seen. Most of the open source projects, typically what they do is, hey, here is a tool to go and install. You pick whatever VM, whatever bare metal, whatever OS you care. It supports these three things. Go knock yourself off. Right? Otherwise, what happens is you get into all these permutations and combinations. Okay, I have RHEL 7, RHEL 6, then you're back to containers, and
well, there's usually an upstream developer. There's also usually a downstream distribution, free to use.
It goes back to the
right.
It goes back to the product.
The bigger
So maybe we spin up a team to work on this sort of thing.
Yeah.
Right now,
I do not like that.
we're doing it. We have what we have.
But that's why we don't need it.
So we have what we have because it was the fastest way to get from Celeste to out there.
Yeah.
You know,
which is a lot better than, yeah.
Well, you guys are playing with it. What do you?
I was going to say that Reddy's comment is why that's so important. I think because that is, in my at least from my point of view, how most open source projects are. Decouple, give me the choice as a developer, or my world, whether it be just comfort with the OS or wherever I work or whatever. I think it makes sense to have that being separate.
It gives you flexibility.
It does. Yeah.
Okay, also, how many hours before you give up though? If it takes 2 hours or 4 hours or 6 hours?
Well, over time though, you'll have downstream distributions that implement sort of best practices that enable like ease of use. Like that comes over time.
If I want a downstream distro, I might as well go with a supported one, and that's how it should be. If you
but guys, so the key part is, the number of dependencies that we have on particular OS.
I'm saying it's easy to
No, I think my point is,
fun to next week. Sorry.
I don't think that it's more than 2 days of work to have this entirely running on Ubuntu, knowing that everything works.
Okay. Anyway, it's in the parking lot. We'll go back to this later.
So all of next week, Ubuntu package.
I'm on vacation.
Exactly.
Yeah.
Ready? You like
You want
to?
You like it? It's a community project. I'm happy where I was. I just download the thing. It's working. So next is lunch.
I can